Unit and Measurements, Chapter 2. In this chapter, we are going to study about following topics: Introduction, the International System of Units, measurement of length, measurement of mass, measurement of time, accuracy, precision of instrument, error management, significant figures, dimensions of physical quantities, dimension formula, dimensional equations, dimensional analysis, and its applications. First, introduction. In the introduction, we are seeing physical quantities. What is There are so many quantities. What is physical quantities? Physical quantities is the quantities that can be measured physically. That's physical quantity. The physical quantity is broadly divided into two. That is fundamental quantities and derived quantities. Fundamental quantities are independent. They can exist themselves, such as time, mass, length, such as independent quantities. They do not depend or do not derive from other quantities. And they are also known as base quantities. And the second division is derived unit, that is derived from fundamental quantities. For example, velocity, speed, acceleration, such things. And the unit of fundamental quantities are fundamental units or base units, and the unit of derived quantities are derived unit. Then what is unit? Unit is internationally accepted reference standard. Unit, we must need a unit to measure something, quantitatively or qualitatively. In the case of quantitatively, there is a well-defined definite unit for everything, every quantity. So, what are the things that we take care when we choose a unit? When we choose a unit that is well-defined, the unit must be well-defined, and the unit is easily reproducible, and is converted from one to another. Everything can be very easily handled and comfortable for everyone, universally accepted. That's the things, and that is very comfortable to measure that quantity, because we cannot measure the size of a nucleus in centimeters, or size of a sun in centimeters is more difficult. So we use a suitable unit as per the purpose. We need a suitable unit. These are things that take care when we choose a unit. Next topic is International System of Units. In early time, different countries and scientists in different countries use different measurements or different units. That makes so many confusions. When we go to British, there is a pound inch system, and so many confusions when Indians, they are feet, idangari, that type of systems. So there are mainly three systems. CGS system. CGS. C means centimeter, G means gram, S means second, respectively. Okay, CGS. In CGS system, we measure length in centimeter, measure mass in gram, and time in second. And in FPS system is a British metrical system, and that is foot, pound, and second, respectively. That is foot in length for foot, and pound for mass, and second for time. And MKS system. Now we accept and we use this MKS system. MKS system means meter, kilogram, second system. And our SI unit system is derived, or it is made from this MKS system, that is most accepted system all over the world. Okay, in SI system, SI means System International de Units, French for International System of Units, and is abbreviated as SI system, the standard scheme of symbols, with a standard scheme of symbols, and with units and their abbreviations. That's most important point. This is chosen by the General Conference of Weight and Measures in 1971. in 1971 in General Conference of Weight and Measures, and that is also known as the rectified or modified MK system. And in that SI system there are 7 fundamental units and 2 supplementary units. 7 fundamental units. First, length. Unit is meter. Symbol is capital M. The definition of 1 meter is the length of the path traveled by a light in vacuum during a time interval 1 by 299,792,458 seconds, approximately 1 by 3 core. Okay, and that is mass kilogram, and abbreviation is kg, everyone know that. Time in second, abbreviation as S. Electrical current in ampere, abbreviation as small not capital letter A. Thermodynamic temperature in Kelvin, abbreviation is capital K. Amount of substance is mole, and abbreviations MOL, mole. Luminous intensity candela, and abbreviations as CD. The 2 supplementary quantities such as plane angle and solid angle. Plane angle is unit is radian and abbreviated as RAD, and the angle is equals to arc by radius. In the case we take a circle of radius 1 centimeter and we cut a sector with arc length of 1 centimeter, we get a central angle as 1 radian. That's equal to actually 1 radian, and theta is equals to length of arc by the radius of the circle. Next, solid angle is SI unit is steradian. When we take a square pyramid of base edge 1 centimeter and slant edge as 1 centimeter, then we get a angle, solid angle on the corner of the square pyramid. That is equals to 1 steradian, and steradian O is equals to area by r square. R square means radius square. And characteristic features of SI system is a metric system of units. It assigns only 1 unit for one physical quantity. No gravitational unit of used in this system. For example, the quantity is mass. That's not weight, because weight is a gravitational quantity, and is an absolute system of units. It's a rational system of units. SI system is applicable for all branches of science such as chemistry, nuclear chemistry, physics, material science, biology, and every aspect of science or branches of science. We use this SI system. It's also known as rationalized MKS system. MKS system is meter, kilogram, and second. And now we are talking about next topic, the range of length. The smallest practical unit of length is Fermi or femtometer. 1 femtometer is equals to 10 raised to minus 15 meter, and we can measure different ranges of length varying from the radius of a proton to the size of the universe. And some unit conversions of length. 1 femtometer is equals to 10 raised to minus 15 meter, and 1 Armstrong is equals to 10 raised to minus 10 meter. 1 nanometer is equals to 10 raised to minus 9 meter, and 1 micrometer is equals to 10 raised to minus 6 meter. And some FPS system units is a foot. 1 foot is equals to 0.3048 meters. 1 inch is equals to 0.0254 meters. 1 yard is equals to 0.9144 meters. 1 mile is equals to 1.609 into 10 raised to 3 meters. 1 nautical mile is equals to 1.8 852 into 10 raised to minus 3 meter. And the other unit of length, such as astronomical unit. This is the average distance from the center of the sun to the center of the earth. If you travel from the center of sun to center of earth, that's impossible, but when we travel, we want to travel, the distance is equal to 1 astrometer, and that value is approximately equal to 1.496 into 10 raised to 11 meters. And light year is the distance traveled by the light in 1 year in vacuum. Some have some confusions about light year. Some they mistaken as the light year is a unit of time. No, light year is unit of length, and the unit of length that is approximately is equal to 9.46 into 10 raised to 15 meters. And parallactic second is a radius of a circle at center of which an arc of length 1 AU substance, an angle of 1 arc second. That's radius is equal to 1 parsec or parallactic second. Then now we are talking about range of mass. We can measure different ranges of mass, starting from mass of an electron, that's equal to 10 raised to minus 30 kilograms, and mass of a universe, that's equal to 10 into 10 raised to 55 kilograms. The smallest practical unit of mass is equal to 1 AMU. AMU means small molecular size of 1 by 12th atom of carbon 12 isotope. 1 AMU is equals to 1.66 into 10 raised to minus 27 kilograms. 1 carat is equals to 200 milligrams. 1 pound is equals to 0.4536 kilograms. 1 slag is equals to 14.57 kilograms. 1 ton is equal to 1000 kgs, and 1 quintal is equals to 100 kgs. Largest practical unit of mass is Chandrasekhar unit or Chandrasekhar limit. It is Chandrasekhar is an Indian scientist. 1 CSL or Chandrasekhar limit is equals to 1.4 solar mass. Solar mass means the mass of sun. The range of time. The smallest practical unit of time is 1 shake. It's equal to 10 raised to minus 8 seconds. We can measure different ranges of time from a lifespan of the most unstable particle, that's 10 raised to minus 24 seconds, and the age of the universe as 10 raised to 17 seconds. And other units are solar day. So everyone know 24 hours. 1 lunar month is equals to 27.3 days. 1 solar year is equals to 365.25 days. Leap year is equals to 4 years. And 1 tropical year, a year with a total solar ellipse. A century is equals to 100 meters. 100 years. The largest unit of time is millennium. 1 millennium is equals to 1000 years. Metric prefixes. First is deci. Deci means 10 raised to minus 1 and is abbreviated as D. Next is cent. Cent means 10 raised to minus 2, abbreviated as C. Milli means 10 raised to minus 3, abbreviated as M. Micro means 10 raised to minus 6. Nano means 10 raised to minus 9. Pico means 10 raised to minus 12. Femto means 10 raised to 50. Atop means 10 raised to 80. Deca means 10 or 10 raised to 1. Hecto means 10 square. Kilo means 10 cube. And mega means 10 raised to 6. Giga means 10 raised to 9. Tera means 10 raised to 12. And peta means 10 raised to 15. And exa is 10 raised to 80.